Hello everybody. This video is going to cover our 8.5 notes which talk about angle relationships and segment lengths in circles. Whew, there's a little bit of a mouthful, apologies. So we're going to be learning a ton of rules in this set of notes. I feel like the last set of notes we did 8.4 had a couple of rules in there, really had a bunch of theorems in there. This one's going to have so many. So I'm going to try to give you things that will help you like remember what stuff is. But you just got to know that there's just going to be a ton of stuff in this set of notes. So I apologize. Okay. First thing that we got to talk about are angles inside of a circle. Now, before we get too far into that, we've already learned, let me zoom, thank you. We've already learned about different angles that are inside of a circle. So we've learned about central angles, and we've learned about inscribed angles. Both of these, hold on, inscribed. Both of these are angles that are inside of a circle. So a central angle is in the center of the circle, okay? If this is 10, then its arc is 10. Inscribed angles, remember that the vertex actually touches the edge of a circle. If this is 20, then the arc is 40. We are not talking about either of these two types of angles, okay? These are very specific places in your circle where your angles fall. One is in the center and then one is on the edge. What we're about to talk about is an angle that is inside of the circle, but is not necessarily in the center of the circle, okay? So we have to do things a little bit differently. So this theorem states, the measure of an angle formed by two chords that intersect inside of a circle is equal to half of the sum of the measures of the intercepted arcs. Mouthful, okay? But essentially all this is saying is I want to find the measure of angle 1. That means that I need to find the two arcs that are created by those two intersecting chords, add them together and divide by 2, okay? So angle 1 is going to be 40 plus 20 divided by 2. We add those two together. 40 plus 20 divided by 2 is 30. So the measure of angle 1 is 30 degrees. I probably should not put that there. I'll put that over here. Okay, so this is 30 degrees. When I scroll on over here to number 2, I'm looking for the measure of angle 1 and the measure of angle 2. Angle 1 is actually created by these two arcs, okay? Angle 2 is not. Angle 2, I mean, the two chords are still intersecting, but angle 2 is across from these two arcs, and I don't know those measures. So I can't necessarily use the formula that I just learned to do that, but I can find angle 1 first. So that's 40 plus 80 divided by 2. And I get 60, so I know that the measure of angle 1 is 60 degrees. Now that I know that the measure of angle 1 is 60 degrees, just as a reminder, these two angles are supplementary because they form a straight line. So I can just do 180 minus 60 and get that the measure of angle 2 is 120 degrees. This example over here is a little bit different because I know the angle that's on the inside and I know one of the arcs, but I'm missing the other. So this is essentially just a backwards problem where I have to add the two arcs together. So x plus 110 divided by 2. It's supposed to give me that inside angle, but I already know what the inside angle is. It's 80. So now I'm going to work backwards. X plus 110 is going to equal 160. I just multiplied both sides by 2. And then I'm going to subtract 110. And I get that x should be 50. And then you can always go back and check, right? We can do 110 plus 50 divided by 2, and it better give me 80. And it does, so I know that I got x correct. Now, x is an arc, so I do need to put a degree symbol there. Okay? Now, angles outside of the circle theorem is essentially the opposite of what we just did. So instead of adding our two arcs together and dividing by 2, we will subtract our arcs and then divide by 2. Now this can get confusing because some kids have a hard time remembering one is addition and one is subtraction, but which one is which. So the way that I like to remember it is whenever you have two chords that intersect, they make a plus sign. Okay, so whenever you have angles on the inside, they are crossing and making a plus sign. Like, is that a perfect plus sign? No, but that's what I do to remember when I have to add and when I have to subtract. So on these down here, what I have to do is I have to find the chords sorry, not the chords. I have to find the arcs that are intercepted, and then I have to subtract those from each other and then divide that by 2. So on this one, because I have 2 tangents, that means that the entire circle is actually getting used. I've got that 60 degree and this 300 degree. So that's the full circle essentially. So what I have to do here is I have to do 300 minus 60 divided by 2, and that will give me the angle on the outside of my circle. 300 minus 60 divided by 2 is 120. So the measure of angle 1 on the outside is 120 degrees. On this example, I don't need the whole circle. I've got this arc down here that is created by those 2 lines, and then this arc right here. You've got to always do the big one, sorry, that's my dog, minus the small one. So 100 minus 60 divided by 2, and that gets me an angle of 20 degrees. When I look at this example here, again, it's the same thing. I need this arc, and then I need this arc. I don't need the other part of the circle because that arc is not created by the 2 lines that I have. So I have 140 minus 50 divided by 2. And I get that angle 1 is going to be 45 degrees. Now we have this guy, okay? This guy is complicated, not really. You're going to see this guy again, and it's going to be on an assessment, and you're going to miss it because you're going to forget how to do this. So this one I would make sure that we know how to do, okay? So in this image here, we actually have the angle measure, and we know that the minor arc or the small arc is x. Gosh dang it. What I do not know is the value of the large arc. What I do know, though, is both of these arcs together are a full circle. So I know that the blue part here is supposed to be a full circle minus whatever arc x is, okay? This is going to be crazy. I told you it will be. So the way that we have to do this is the blue arc minus the green arc divided by 2. This is, oh, and then it has to equal 40. Okay, that's what this is. It's 360 minus x. That's the blue arc. And then minus x is my green arc. So it's those 2 arcs that are being subtracted from each other, which is funky. It's not 360 minus x. It's 360 minus x again. Okay, this is important. I'm running out of space. This will be 360 minus 2x equals 80. I just went ahead and multiplied both sides by 2. I'm going to subtract 360 from 80. So 80 minus 360 is negative 280. So right now I have negative 2x equals negative 280 divided by negative 2. And I get that x is equal to 140. So what that means is this arc right here is 140 degrees. Now I can double check and make sure that my math is right. I'm going to do 360 minus 140, which means that my blue arc is 220. So I've got 220 minus 140 divided by 2. It better get me 40. 220 minus 140 is 80. 80 divided by 2 is 40, so I know that I did that one right. Again, this one you're going to see again. You really need to make sure you know how to do it. It's not super complicated once you look at it and think about it in terms of being a full circle, but it is something that we have a hard time remembering, okay? And then this last one is one I've already seen. This is 74. This is x. It's still a backwards problem because I actually know what the outside angle is, but you have to do big arc minus small arc divided by 2 equals that outside angle. X minus 74 equals 64. I'm going to go ahead and add 74 to both sides. And you get that x is equal to 64 plus 74, and that is 138 degrees. And there you go. Okay. All right, so here's an example where we have to use the same property that we just talked about. However, there's going to be some stuff going on here. So we are given that the measure of angle B is x. That's my outside angle. It tells me that the measure of arc DE is 2x minus 20. And then it tells me the measure of arc AC is 3x plus 17. They want me to find what x is. So I have my small arc, and I have my large arc, and I have my outside angle. So what I have to do is I have to subtract the arcs from each other. The problem we have here is my smaller arc is comprised of more than one term. It's a binomial. It's got 2 terms in it. So I have to put it in parentheses when I subtract. It does make a difference, and you will not get the right answer if you do not do that. Okay? So this will be 3x plus 17, and then you have to distribute this -1 that is on the outside of that parenthesis. So you will get a negative 2x plus 20 divided by 2 equals x. All right, you get 1x plus 37 equals 2x. So I went ahead and I combined my like terms, and then I multiplied both sides by 2 to get the 2 out of the denominator. All right, and then now from here, all I have to do is subtract x, and you get that x is 37. This one you will also see again. I would definitely make sure you know how to do that. Can't forget about this right here. Importante. Okay, we are moving on now to looking back at angles inside. So remember that when you have angles that are inside, this is where you have to add together. You have to add the arcs together. So I've got arc AB and I've got arc CD. Angles 1 and 2 are vertical angles, so they're going to be congruent to each other. But let's go ahead and label what we have. CD is 11x, and then the measure of angle 1 is 9x plus 4. Okay, I need to add my 2 arcs together, divide that by 2, and that's supposed to equal the inside angle of 1. I don't know why it asks for 2 as well. That's weird. Whatever. Okay, I'm going to go ahead and multiply both sides by 2. Remember that when you multiply this side by 2, everything gets multiplied by 2. Whoopsies. So this is going to equal 18x plus 8. I'm going to move both of these things over here by subtraction. So we have x squared plus 11x minus 18x minus 8. That will equal 0, and now I'll be able to factor. I'm going to scoot this over so that I have some more space. All right, we got x squared minus 7x minus 8 equals 0. When I factor this, I get x and x. I get 8 and 1. I need a -8 and a +1. X minus 8 equals 0, and x plus 1 equals 0. So x is going to equal 8, and x is going to equal -1. I need to test both of them. If I plug in -1 down here, I'm going to get a negative arc length, which doesn't work. So x will only be able to be 8. X is not by itself anywhere, so I don't need a degree symbol. Okay, one of my favorite examples, example 3. We've got inside angles, outside angles, intercepted arcs, no central angles though, okay? All right, I'm going to label what I know. I know that arc AC is 142 degrees. I know that the measure of angle AFC, so that is this angle here. Let's do pink. I know that this angle right here is 93 degrees, and it says find the measure of angle ABC. The measure of angle ABC is this angle here. In order for me to know that angle, I need both of my arcs that create that angle, which means that I need to know what this arc is, but I don't. However, what I can do is I can use my inside angle, this arc, and I can label this one as Y and find it. And once I find arc DE, then I'll be able to use arc AC, subtract arc DE from AC, divide by 2 to find B. So this one's a 2-step. Step 1, I need to do, first I need to write that nicer. I need to do Y plus 142 divided by 2 equals 93. Y plus 142 equals, whatever that is, 93 times 2 is 186. Subtract 142 from that, and I get that Y is 44 degrees. So that means that this arc right here is 44 degrees. So now that I know that, going to shrink this just a bit. So now that I know that, I can come back in here and I can do 142 minus 44 divided by 2, and that's going to equal my outside angle x. So 142 minus 44 divided by 2 gets me 49. So that outside angle x is going to be 49, so the measure of angle ABC is 49 degrees. Okay, that's a two-stepper. Okay, moving on to, so these are all angles and arcs, okay? Now we're going to be moving into rules about segments. So this could be chords, these could be secants, these could be tangents, or a combination of these things, okay? This theorem states, if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Remember that product means multiplication, okay? So essentially what they're saying here is, I'm going to color AC pink, I'm going to color BD blue, and really we have A times B will equal C times D. That's what the rule is, okay? So the rule is A times B equals C times D. So now that I know that, I can use that down here. I'm going to do the exact same thing. I'm going to duplicate it, scooch it on down, okay? And I'm going to label what I know. So I'm not going to have A, B, C, and D, but I am going to write it in their colors. So BE, that's blue, BE is x plus 2, ED is x plus 1, so those are both blue, and then AE is x, and EC is x plus 4. So I'm going to take those two pink segments, multiply them together, set it equal to the multiplication of the two blue segments. So we have x times x plus 4, and that is going to equal x plus 2 times x plus 1. Okay, so we have x squared plus 4x equals x squared plus 3x plus 2. So that's just me skipping some steps. X squared plus x plus 2x plus 2. Okay, x squareds cancel. I'm going to go ahead and move my 3x over. So we have x is equal to 2. Well, that was easy. X is 2. Okay, there you go. All right, another theorem. So this theorem talks about two secants. Okay, so remember that secants at least have to exit your circle at least one time. Okay, typically twice, but no matter what, they at least have to exit the circle once. Okay. So it says two secants share the same endpoint outside of a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. Woo! Okay. Let's talk about it, shall we? This one will be blue. This one will be pink. We have A and B, and then I need you to do this. A plus B. Down here we have C and D, and then I need you down here to do C plus D. So before I'm going to erase this and do it and fill it in a second, okay? When you look at just the pink line right now, little a is considered the outside portion of your secant. That's the external piece, okay? Little b is the internal piece. Little b is a chord, okay? A plus b is the entire secant segment, okay? When I look at two secants, what's really important to me is remembering that I have to use the outside portion more than once. It is on its own, and it is part of the full segment here and here, okay? So the way that this rule works is you have the outside portion times the full segment length. So A, which is the outside portion, times the entire secant, which is A plus B. And that is going to equal, on my other secant, its outside or external portion times the full secant together. okay? An easy way to remember this makes me giggle when I say this, is out. Outside times the whole segment equals outside times the whole segment, out. Okay? That's what it looks like. It's gnarly. I get it. But that is how we do this, okay? My suggestion is always when you do this to doodle it exactly like you see me having it doodled here. You are going to aggressively circle the external segment like I did for both A and C. Circle it because you have to use it twice. And then if you want to underline or circle or do whatever to remember that you're using the full secant segment, that A plus B or that C plus D, do that, okay? Let's test it. La, 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 la. There's that. There's that. Okay, now I'm going to label. What was I given? AB. AB is x plus 2. X plus 2. Circle it. Circle it. BC is 2x minus 8. Now, we need to add those two segments together. So x plus 2x is 3x, and then positive 2 minus 8 is negative 6. Hopefully everybody can see that, okay? Then AE is x plus 1. Circle it aggressively. And then ED is 2x minus 5. And then we need the whole segment. That is 3x minus 4. Okay? Remember, this one's out. So I need the outside portion, x plus 2, times the whole secant segment, which is this guy. Okay? And that is going to equal the outside portion, which I have aggressively circled, times the whole secant segment. 3x minus 4. And then we do the math. This is 3x squared minus 6x plus 6x. Ooh, that cancels. Minus 12 equals 3x squared. Oh, my God. 3x squared minus 4x plus 3x minus 4. Man, we've gotten really lucky with these factoring problems. We don't always have to factor. All right, so we get negative 8 equals negative x. Therefore, x is equal to 8. Okay. Okay. Next. I think this is the last one, actually. It is. All right, so this theorem states if you have a secant and a tangent, and they share a point on the outside of the circle, then the product of the lengths of the secant segment and its external segment, which is exactly what we did up here, OW, outside times whole, is going to equal the square of the length of the tangent segment. So here is your, I'm going to do the secant segment in pink because we already know that one. I'm going to do this one in blue. All right. This is A times B. This is A plus B. We want this, and we want this, and it's just going to equal this side squared. That's it. That's all it is. Okay? So this will be A times A plus B, like the other secant segments were. And now we're just going to equal this side squared. That's it. That's the only difference. So anytime you see a tangent, it's going to be that value squared. Anytime you see a secant, it's outside times whole. Okay? So here we go. EA, ED. What do they give me first? They give me EA first. Okay, EA is 6. Lovely. Squared. Okay, and then EC is going to be X, aggressive. CD is going to be 9. We go X plus 9. I need this. And we do X times X plus 9. That is going to equal 6 squared. Not bad. X squared plus 9x equals 36. We're going to move that over. X squared plus 9x minus 36 equals 0. X, 12, and 3, I believe. And we want a positive 12 and a negative 3. So x will equal negative 12 or x will equal positive 3. Sorry, my dog is being crazy. X cannot be negative 12 because we cannot have a negative length out there. So x has to be 3. And you guys, that's it, okay? Lots of rules. I totally understand. It's a little crazy. I get it. But just know that these things take practice, 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 okay? You'll be fine, I promise. If you have any other questions for me, please go see your teacher during their normally scheduled tutorial times, and I will see you in the next video. Bye.